Salutations, mini mathematicians. We're going to be filling in our properties list here. So if yours isn't labeled like mine is, let's just label this properties. So these are some math properties. Some of them you already know, and we've been using them already this year, and all of them you'll need to know in your future math classes. So the first one is the identity property of addition, or the additive identity property. It says that a plus 0 equals a, which means adding 0 to any value or term, we could call a term here, does not change the term or the value. So some examples, this works for natural numbers. 8 plus 0 is 8. It works for integers. -7 plus 0 is still -7. It works for rational numbers. 2/3 plus 0 is still 2/3. Works for any real number. The next one we're looking at is the identity property of multiplication, or multiplicative identity property. So very similarly with the additive identity property, we added a number to something and it didn't change it. Here we're going to multiply a number by something and it's not going to change it. What can I multiply by any number and I still get that number? You're right, it's 1. A times 1 is equal to A. Multiply a term by 1 does not change the term. So let's show a few examples here. 1 times 1 is 1. -12 times 1 is equal to -12. 2/3 times 1 is still equal to 2/3. Works for all the real numbers. So taking a look, the next one is the multiplicative property of 0. And we know this one very well. If you have 0 groups of something, you still have 0. And if you have a group of 0, you still have 0. So we'll continue with A. A times 0 is 0. So multiplying any, we can say term or value. I'm going to use term here. Any term by 0 results in 0. So if we look at these examples, 1 times 0 is 0. -9.52 times 0 is 0. 2/3 times 0 is 0. Works for all the real numbers. The next one is the commutative property of addition. You've probably seen this before. So when we see the word commutative, I like to think of the word commute, meaning you're moving from one place to the other. I live in Carlsbad right now. I work at Earl Warren in Solana Beach, so I commute from Carlsbad to Solana Beach. I move. So the commutative property of addition, here it says changing the order of addition does not change the result. So if you had A plus B, it's adding 2 terms. That's the same thing as B plus A. So notice the numbers actually move. So if we look at a couple examples of that, this works with rational numbers. 1.5 plus 3.2 is equal to 3.2 plus 1.5. Works with fractions, other rational numbers. 2/3 plus 5/8 is equal to 5/8 plus 2/3. Works with 0. 0 plus 1 equals 1 plus 0. 0, a whole number. Works with natural numbers. 7 plus 4 is equal to 4 plus 7. Works with all the real numbers. The next one is the commutative property of multiplication. So very similar as the commutative property of addition, if you change the order, if you move the numbers, you still have the same result or the same product. So changing the order of multiplication does not change. You can say the result or the product. I'm going to say the product because that is the answer to a multiplication problem. So let's use same numbers as above, but now we're just multiplying. 1.5 times 3.2 is 3.2 times 1.5. Remember, we don't like to use the x for multiplication because it might be confused as a variable. So I like to use parentheses, or you can use a multiplication dot. I try to avoid using a multiplication dot with decimals because then we just have little dots everywhere. 0 times 1, same thing as 1 times 0. 7 times 4, same as 4 times 7. So again, the numbers are moving. Where it's a little bit different with the associative property. So the associative property of addition has to do with regrouping. So it has to do with regrouping. And of course, I have a little rhyme for you. Associative property has S's and C's. That's what moves those parentheses. So here with addition, if you have 3 terms being added together and 2 of them are grouped, we can change the grouping of what we add first and we still have the same result. So notice the order stays the same. It's still A, B, C. So a big hint about when we have associative property is if the order is staying the same, but just the grouping changes. So here, changing the grouping of addition. Does not change the sum. I'm going to say sum. You could also say result if you wanted to. Again, if you look at these examples, 1 plus 2 plus 3, 1 plus 2 plus 3, the only difference is that here we're going to add 2 and 3 first to get 5 and then add 1. Where here we're going to add 1 and 2 first and then add 3. Both of them get us 6. So again, remember the numbers don't move, it's just the parentheses that move. Associative property has S's and C's. That's what moves those parentheses. Let's flip the page over. The next one is the associative property of multiplication. So very similar to the associative property of addition, except now we have multiplication. We still have our little rhyme. Associative property has S's and C's. That's what moves those parentheses. So we will have A times B times C, and we're going to group the B times C together, is going to be the same as, we still have A times B times C, but we're going to group the, A and the B together. A times B times C, we're going to group the A and the B together. So changing the group of multiplication does not change the result. So if I have 4 times 3 times 2, where I have the 2 and the 3 being multiplied together, I have 4 times 2 times 3, and then I have the 4 and the 2 being multiplied together. Here I'm still multiplying the 4 times the 2 to get me 6, and 6 times 4 is 24. Where here I multiply the 4 and the 2 together first to get 8, and 8 times 3 is also 24. And this works with all types of numbers. So 2/3 times 5/8 grouped together, then times 3/4 is the same thing as if I had 2/3, but I multiplied the 5/8 and 3/4 together first. Perfect, great job. The next one is the distributive property of multiplication over addition. And typically we just call this the distributive property. But what's happening is you're multiplying or distributing one term to a sum or a difference. So this is A groups of B plus C is A times B plus A times C. So we're distributing that number on the outside. So we call this A groups, thinking about our multiplication model, of B plus C. So this works with all sorts of numbers. If I have 3 times 2 plus 5, that's going to be 3 times 2 plus 3 times 5 if you had 7 times 3 minus 2, that's the same as 7 times 3. And I like to always rewrite it as addition, plus 7 times negative 2. Wonderful. Very nice, very nice. The next property is really important, and we've looked at this already when we were looking at our chip models, and this is the additive inverse property, or the inverse property of addition. So we've talked about how the additive inverse property is a number and its opposite, and we know that a number added to its opposite is going to get us that additive identity, which is 0. So a term added to its opposite results in 0, which is the additive identity. So if you see 1 plus negative 1 is 0, negative 6 plus 1 plus 6 plus 1 is 0, 2/3 plus negative 2/3 is 0. So additive inverse property tells us that a number plus its opposite is 0. Another inverse property we've talked about in class is the multiplicative inverse property. And we talked about how the multiplicative inverse property is the same thing as a number's reciprocal. So we talked about how multiplying a term by its inverse or reciprocal will result in 1, and 1 is the multiplicative identity. So add those notes to that. So our example is A, and then the reciprocal of A would be 1 over A is equal to 1. Notice we can't have A equal 0 because we can't divide by 0. And again, if sometimes these variables are abstract to you, you can always look at that numerical example to help you out. So if we had 5 times 1/5, that's going to get us 1. If you had 2/3, we'd multiply that by 3/2 and we'd get 1. Very nice job. We have 2 more properties. So the substitution property, sometimes we may think about it as the simplifying property. It just means to simplify. It tells you that A is equal to B, or A may be replaced with B. And if you look over here, we had 3 times 2x plus 20 is 6x plus 20. So they're just simplifying or substituting 3 times 2x is equal to 6x. And here we have 3 plus 5 groups of y is equal to 8y. They're just simplifying or using the substitution property, saying that 3 plus 5 is equal to 8. Really nice job. The last property is one we've used a lot this year. It's the definition of subtraction, which tells us if you're subtracting a value, that's the same as adding its opposite. So subtracting a value is the same as adding its opposite. So if I had 3 take away 5, we know that's the same as 3 plus negative 5. If you had 7 minus negative 4, that's the same thing as 7 plus the opposite of negative 4, which is positive 4. Excellent job, mini mathematicians. Remember, you're going to be using these properties throughout this module, the next module, and even next year. Great job. We'll see you next time.